All right, so as we know that log monitoring has been an important part of every software industry these days. So when we talk about the real DevOps stuff, it has been very much important to go ahead and take a look at the reliability using the predictive um, log analysis and anomaly detection. So if we talk about the anomaly detection, now in anomaly detection, uh, if we have the right logs in the logging system, we can take a look at how these logs are basically ingested, how these logs are generated by different applications. If I talk about UKG, in UKG, we are utilizing this for process monitoring. Now, let's take an example of it. Now, what we do, we have built in those trends, and when we look at those trends, over the period of time, if you see there's a dip in trend. For example, my process is working and there are 100,000 processes that are currently working. And if you look at a dip, certainly that yes, my process count came down to 800, something like that. So then what AI will do, it will just go ahead and it will generate the alerts. It will mark that on the dashboards, and we can go ahead and generate those alerts using PagerDuty, using alerting, so that we can take the proactive steps. So if those logs wouldn't have been there, and if we are going ahead and taking a look at, we won't be taking a look at those logs, and we're not doing this proactive monitoring and predictive analysis, it would have been difficult. And MTTA and MTTR, in terms of responding to our customer, that becomes high. On top of that, MTTD, which is mean time to detect, has become very high. So this is how log definitely helps in the reliability. Other important area that I would like to suggest is, or very important, is threat modeling. If we look at the threats, security threats that are happening. So these logs definitely give an insight to those security threats. What are the different requests that we are getting? And based on the number of requests that we are getting, how many of them are failing, how many of them are passing, and we suddenly see there is an influx of logins to the applications, we should be able to go ahead and do that security threat modeling too. So that helps in preventing the system and going down. The third aspect is the performance. If we look at the latency views, as the application, these logs will give you a lot of insights into how application is behaving, how it's performing, what is the latency that's coming in. If we can go ahead and look at that latency and generate an alert for respective teams, the teams can go in, find out those issues, solve those problems even before customer detects it. So this is how logs are definitely important for reliability. Yeah. Yeah.
I'd just like to, add to that. So I think, see, log has been the traditional method, right, with respect to, a go-to method, right, with respect to managing anything, with respect to troubleshooting your issues, right. But what we've seen is this has evolved, right, over a period of time when observability and site reliability engineering practices have kind of developed, right. What we've seen is in today's world, logs are obviously used, but then more important things are metrics, traces, events, right? So these are more important components which also comes into picture when it comes to troubleshooting your issues, right? Log monitoring definitely helps, but then it takes a little bit of time, right? And observability as a whole, by combining all these different metrics, traces, and events, has kind of streamlined this entire process and made it a lot more quicker, right? And there are a bunch of tools out there in the market who's actually actively doing this process, to streamline things.
Yeah, just to add one thing to it, that apart from what Sachin and Jasprit has said, there is a feature called auto being also need to be implemented in the log monitoring. Like as soon as you get an alert and it gets there and automatically a lambda or something that is fired, you can automatically
think basically it's a very common problem. The challenges are because of the cost, increasing cost, making an efficient search and all those things. So the general practice is like you having a logging into a central place, which is a very common as well, like using ELK or any other tech stack for centralizing it. Then also tuning your logs, say defining the metadata in every log line. How we do is that we have a common library across different services, so that all the request ID and the metadata which is important for our developers to analyze the logs is available, and it is and we will be able to index the right sort of things, so that it is become queryable faster. Other thing is that having a good retention period, well, the retention which you need. So there could be, say, for our 3 days logs, what we do is we keep it into a much faster, or as in the high cost storage, and the other logs you can move it to an S3 where you can have a latency in place. Say for example for a month's log if you need it, right? Other thing is that you can do or practices that purging the policy which is there, and also reviewing the log practices which are so basically we defined a standard that we'll capture only the debug and an error logs. Then the developers becoming smart and they started keeping an info logs as well into a debug mode. Then on a periodically basis keep reviewing the practices which is there, so that you don't bombard your central logging system with a lot of logs. So I think that's all. These are the practices which you can follow.
And just to add, like usually what the developers do, it's not against the developers, like they turn on the debug log and then it prints the log in like kilos and megabytes and other things. So we need to make sure like they follow that practice, that only those logs which are actually required for those period of time, they can enable that, and that practice should be followed up.
Correct. That's what. Regular monitoring and checking on the practices which you've been, defined for the engineering team to follow is getting followed. And it's very, it should not be like you have just defined the practice and it is not getting checked. So and it should be like once in month or once in quarter maybe if your practices are aligned by the team.
I want to add a perspective to what he just said, and you said that there have been the practice that developers just go in and then put in the debug logs. So that's where a lot of tools which are available in the market helps us, wherein we can just go ahead and filter them out. And if we filter them out, then what happens? To your actual log system, you are pushing only those logs that needs to be analyzed. And we can put the rules on the logs which says that, yes, these are the logs which are debug logs or info logs or the system print logs. All of these logs should filter out and go to a separate database where they should be purged at regular interval. So we are keeping our logging system, we are keeping our real logging system clean, from where we can go ahead and really mine the data to take some concrete action on it. Yeah.
Right. Thanks, Sachin. So the next question, Sachin, again to you. Like we all been hearing about ChatGPT, Copilot, and there are multiple tools which are coming into the market, and everybody is talking about the operational efficiency, productivity, and everything. So how it is actually impacting? Is it actually in the AI when we say, is it actually helping the developers or the DevOps or anybody, or it is just a buzzword which is again like SRE or anything like that?
I think that it is actually helping.
Okay.
Because I can talk about UKG. In UKG, we are using AI to monitor our logs.
Okay.
We are for our observability. And using the AI, we have been able to go ahead and detect some of the anomalies early in the cycle.
Okay.
So what we do, we just look at those patterns. We are looking at how the infrastructure is behaving, how your application is behaving, and generating the right set of alerts for the customer, for the developers also at right point of time. So if there is a notification that need to go out to the customer, we usually tell them. Otherwise, like we are sending out pager duty alerts or emails to our application. Now, if we look into that, Netflix also uses the similar kind of model. So if you look at Netflix, they are also building the observability predictive analysis. They are going ahead and looking at the CPUs monitoring and infrastructure monitoring. That's all through the predictive analysis. And another good example which I want to talk about is Google.
Sure.
Now, Google manages its entire hardware with AI and with the observability.
Right.
Now, what they have done, they went ahead, they put in the sensors on their hardware, and those sensors are sending the data, and the logs that are being generated, they are correlating that data, and as soon as they see there is a hardware problem, they go ahead and switch the hardware and switch the application to different hardware and put that hardware into the maintenance mode.
Great.
Another example that I want to take is Azure. Now, if you look at Azure, it is using AI to monitor the health of VMs, to monitor the health of the containers that they have, because they are into a business wherein they require more than 3 nines of availability. Okay, probably in some cases 4 to 5 nines as well. But how they are doing it? It is humanly impossible if we look at the amount of logs that are being generated. So they have built an AI engine on top of that to monitor the health of containers, to monitor the health of VMs, and then they are rotating those VMs. They are, in case they see any challenges. So yes, this is not a buzzword. This is something, there are real applications to it. And I would say that we are using it today, right?
Yeah.
Okay, thank you.
Okay, so I take my words back. Surya, do you want to weigh in on this particular thing, like AI? How about AI is helping in your organization or across the particular thing in DevOps?
Yeah, so definitely, you know, a lot of technical folks are these days using all the AI tools to learn faster also. It's not just in terms of, you know, trying to get a solution out of it. But, you know, when it comes to AI ops, I think AI also comes with certain risks in terms of whether it's human or AI. I think, you know, there is always some bit of bias that always comes. So the kind of data that we send to AI, right, it has to be more diverse. And that's where I think organizations might face challenge on how to send that diverse data. Because, you know, if it is a monotonous data that keeps going to the system and, you know, the AI gets trained on it, suddenly if there is a critical error that comes, AI might miss it because it's not trained on it. So I think we still have to wait and watch in terms of how AIOps as a field will mature and evolve in the days to come. That's what I would say.
Thanks, Surya. There was one interesting study which was done back then by the Google itself, which Surya has just mentioned, like the data which has been trained on top of it. So when they showed the pictures of like African American in America itself, and they immediately the AI tool has told like this is not a person, it's a something else, or gorilla or something like that. And because it was a mistake from the training model on which they were doing this particular thing, that was has to be done correctly so that the diverse perspective can be taken. If we are taking one perspective and training the data, it might be prejudged and it will be giving a false results for that. So, yeah.
I'd just like to add on that, Mayank. So I think, you know, as Sachin rightly said, right? So this is not a buzzword anymore, right? This is as good as a reality these days. One thing which is extremely important to understand is, you know, one of course is that AI is obviously evolving technology, but that has also touched a lot in the observability and SRE space, right? People are using AI these days to make sense out of different pieces of technology, club them together, and then resolve their issues faster, right? One more example I could give is predictive analysis, like just what Sachin was mentioning, right? So, imagine a situation where, you have an upcoming sale, and in next 2 days, you expect your CPU to, let's say, exceed up to 80%. In normal situations, you would have to wait for an alert to trigger before you put some action into it, right? But these days, maybe tools like Datadog, we give you predictive analysis and give you forecast that, this is the problem you're going to encounter. So make provision for, put some resources and, basically avoid those issues as much as possible. So I think, yeah, it's very much real.
Right, and it goes back again to like how on which the data particular thing is being trained on. If the data is accurate enough, it will be trained really well. So the next question goes to Avinash. So which automation technique proven more efficient in accelerating software delivery without compromising quality? Usually we always talk about quality and quality gates and everything. So this for you.
Yeah, so I think automation in general actually helps in achieving both, speed as well as quality, because manual task is always prone to errors.
Right.
So when we talk about automation, CI/CD, containerization, and then orchestration tools such as Kubernetes, so they have been in the industry for long, and most of the companies nowadays are using such tools to automate most of the DevOps activities. Few things that I would like to highlight that we at Physics Wallah are using right now. So one thing is feature management using flags. So we have, when we have gating on the basis of flags, it helps us roll out changes to the production environment very quickly, and the features are gated. And then it is also helping even the product teams to actually test the products, various variations of products. They can test with multiple set of users, and even in the larger changes. For example, we were working on separating microservices from like a single service.
Right.
So it helps us quickly, switch off the traffic to a particular service, or let's say we want to send only 10% of the traffic to that particular service. So all of that can be done using feature flags. Then another thing that we have used is canary deployments. So it is helping us even larger set of things. For example, let's say we have to upgrade a package, or we want to upgrade the runtime environment. So Canary is helping there, because we have now 2 set of parallel deployments, 2 versions of the same application, and we can quickly roll back. We can control the amount of traffic that we are sending to either of the version, and we can actually roll back very quickly. And we are even right now working on automatic rollbacks, which you were also mentioning earlier, right? So in case there is any, let's say the error rate increases after a deployment, it can automatically roll back the Canary deployment. So I think this is very much helping us, even both, increasing the speed of the deployments that we are doing, and also, maintaining the quality. Another aspect that we have covered is IAC. So most of our infrastructure provisioning has been moved to IAC now. And this is something we started when we actually started working on the DR strategy for our infrastructure. So that's when we realized, having a IAC in place will actually help us streamline all the environments, plus all of our workloads. So we are put up in 2 regions now, Mumbai and Hyderabad. So provisioning the infrastructure and making sure the DR implementation is done at a speed. So we were able to achieve those things using IAC to a great extent.
Yeah, thanks Avinash. So I'll ask Vibhor if you can pass the mobile. When we are talking about this DR strategy, so how you are doing the DR, like how best the DR you are doing, because usually the AWS Hyderabad came up very recently. Back then everything was in Mumbai. So how you are doing the DR and other things?
So as of now, we are using in Hyderabad only. So I think the Bombay and Hyderabad is our Hyderabad our DR side, and I think we've been using all the managed services of AWS for managing our DR. Say for example, Aurora DB, it's side to side. Yeah.
Okay. And Pratap, For the AI part of it, which Sachin was talking about, so what's your take on it? Like, are you using AI for anything? Is generative AI you are using in your team?
Not much, to be
Okay.
honest.
Hmm.
But yes, we are leveraging somehow. Typically, if I'm talking about DevOps, not
Right.
for the dev side,
Right.
not much. But yes, what I see, particularly when we talk about the AI ops,
Mm-hmm.
there are many things which we can offload,
Mhm.
right? And this is where we are heading. Basically, you can have a self or a model where you define what needs to be done. You can put the guardrails and let the people own it. Basically, not the DevOps people should be doing that. That is how we are leveraging few of the aspects of AI
Mhm.
ops. Not we are just moving forward to it. We'll say that we are at a very initial stage to
Right.
right? Because there are so many things which you can do with AI ops, and we have to learn a lot in that area typically, right? Because there could be things where whatever you're building, because you have to have a data to train your AI models. And most of the time, what I've seen from my past experience to present, right, when you typically depend on the AI ops, your models are biased, not trained well, because you have to have variety of use cases where your models has to be trained and matured enough. That's where AI ops creates sometimes bias, and if you're depending 100% on that, you will be having issues. So yes, we are moving towards it. I'll not say that we have matured yet.
Okay. Okay. So the next one was for you only. So how can CI/CD pipeline be optimized for different application architecture, including microservice and monolithic?
Okay, this is one of my best area. I'll say that one of the interesting area where I'll put a lot of efforts personally, and my team is also in past and present have contributed a lot. Uh, Monolithic versus microservice, I'm not covering in these things, but if I have to support both, right, and which we have done, coming over more than a decade, a couple of decades, I'll complete soon. Experience for monolithic, the major problem which we have seen, like uh, speed. That is where you can implement incremental builds, right? The another thing which we face, or generally typically people face, is this is integrated testing, which is very simple with the you are on the microservices. You can have a granular deployment. You have different services which you can deploy quickly. But monolithic, it becomes a comprehensive testing which is required at the early, and incremental builds help that move fast. If you build, if your the code has been shipped, then you are building everything from the scratch every time. Obviously, it is going to slow delivery. That is where you have to implement incremental builds. And coming to the microservices, it is now everyone is using it. It's not a buzz anymore. When I came from the background when we have been doing monolithic, then moved to microservices. It is easy, granular. You have faster deployment, faster testing, and segregated test environments. This gives you a better speed. The main challenges which we have with this, the major problem comes with environment parity. Like if you do not have environment which is identical, like dev stage production, right? That is where you will face most of the problems. That has to be fixed. Second part, obviously you have to integrate security in that. This could be your one of the choice if the company is focused toward that. If we are managing both of these things, we will have better speed, better control, and obviously stability will be guaranteed.
Okay. So just add-on question, like is when you are doing the deployment, is it a complete downtime, or you are taking any downtime for the production?
No downtime. We are sitting here and when we are talking about AI and all, downtime are not expected. I will tell you, when we don't care about what time it is, we are deploying, right? Currently, because earlier, if you see before 2010, we used to wait for, okay, if it is 12 o'clock in midnight, then we'll go for a deployment. No? So that is, we don't even care for what time it is, and we go ahead, we'll deploy it. And we deploy at a scale also. So scale is also not a problem, right? Because I have seen where we had 70,000 servers to where we had to do the deployment. It is not the code, it is part of some infra deployment and all. That is where we don't see the challenge anymore.
Okay. Thanks. Thanks, Pratap. Next question, Surya, can you pass on the mic, please? Yeah, so the next question is like, what unique consideration and strategies are essential for CI/CD pipeline implementation in hybrid environment? Like when we are having both kind of like on-prem as well as you are having a cloud.
Yeah, so that's a very interesting question. So before I answer to the strategies for hybrid, I would like to first tell why do companies get into the hybrid model. That's first thing we all need to understand, right? So I'll talk about 3 levels of complexity that typically happen with companies. So I'll take a small use case to make it more engaging. So whenever companies start embracing cloud native, say for example, they choose a vendor like AWS, and CI/CD, the marketing team comes and says, okay, AWS code build and code deploy, code pipeline, so life becomes easy. Over a period of time, I think the operational expenditure keeps increasing. And that's where I think companies start saying that, okay, for the non-production, non-critical loads, let's not use cloud. Let's buy or invest a bit of capital and have some, on-prem servers, maybe a private cloud, so that, the production workloads stay on AWS, right? And that's the first level of complexity that people get into. Now, obviously, the AWS CI/CD tools won't work in the private cloud. So maybe for, say for example, these 2 aspects of infrastructure provisioning and CI/CD, the teams might start using something like Terraform and Jenkins and so on and so forth. And then, in networking events like this, people meet other competing cloud vendors, say GCP, which would offer heavy discounts. And that's when, over a period of time, we also realize that we should not get into vendor lock-in and slowly start shifting load from AWS to GCP.
Right.
And then the second level of complexity starts where we have a hybrid cloud and also we have a multi-cloud. So what do we do now with infrastructure provisioning and the CI/CD tooling? Okay, so maybe something like Spinnaker. And then if companies have regulations and they want to span to multiple geographies, then it goes into the third level of complexity of multi-region. Say for example in Middle East, Europe, US, Asia Pacific. So I think this is for most of the teams and companies that I've seen, this is how the evolution happens, where it's not just the hybrid part, but even the multi-cloud and multi-region. And when we have this kind of combination, how do we actually achieve, say for example, companies are very cost conscious, they want to reduce their operational expenditure, that's level 1 complexity, don't want to get into vendor lock-in, and also have multi-region. I think the prescription that I would give to the viewers is, when it comes to infrastructure provisioning and CI/CD, always prefer for cloud agnostic tools. Say for example, Terraform for infrastructure provisioning, which works whether it's AWS or on-prem or GCP. Second thing, of course, if it is a microservices architecture, Dockerize and use some container orchestration tool like Kubernetes, because Kubernetes has good support both for AWS EKS and GCP GKE. Beyond that, I think the CI part can be achieved with any of the tech that we have, like Jenkins or GitLab CI or GitHub Actions. Particularly when it comes to CD, we at GreytHR actually use Kubernetes native tool called Argo CD. So in such cases, I think Argo CD works really well, even in case of the hybrid, whether it's the on-prem private cloud or the public cloud, AWS or GCP. It's one tool which can actually make sure that the deployments are seamless. So I think these are some of the strategies that I would prescribe to the viewers. Yeah.
Thanks, Surya. Sachin, you wanted to add anything?
No, I think that most of those things have been added, but when we are talking about multi-cloud experience, so the only thing that I would like to add is creating the application that can be deployed across the cloud has been a real challenge these days. And when we are doing that, we need to make sure that our Terraform code that we are writing, the Ansible code to spin the infrastructure that we are going to write, that is segregated correctly. Our CI/CD pipelines that needs to go, that are deploying the code into multi-cloud infrastructure. So those CI/CD pipelines are robust enough. On top of that, we have to ensure that the testing And the test cases that are associated with each of those cloud structure, they are there and they are testing it out thoroughly. Because the most common pitfall of this is we assume that whatever works here should work on other cloud too, which is wrong strategy.
Right.
Yep.
Thanks. Thanks. Avinash, I just wanted to ask, because I think though in this questionnaire it's not been mentioned, one thing which we miss and we don't talk much about is the branching strategy. That is the core of everything, where everything starts, and once you mess up with that thing, you create 2,000 branches, everybody is creating their own branches, and then at the end of the day, what we are doing as a DevOps person, we are the one who are actually cleaning that up. It's a mess created initially, and then we are cleaning it up. So how to make sure like we have a better branching strategy, and what process should we put in place?
So I think branching, so I mean, you rightly put it. So a couple of months back, we were actually discussing on this very problem, you know, how do we standardize our branching strategy? So I think in general, so feature branch is something that we work with, which every developers, you know, they create their own feature branches, and eventually when a feature, even if it is coming in from multiple developers, so it goes into the single branch, and that is what is merged to, let's say, the staging environment or even the production. But in general, all of this actually impacts, let's say you have too many developers working on the same service. So then, you know, managing the code, managing the conflicts becomes a challenge, right? So there is another concept, which is trunk-based development. So I think that is something which is very lucrative in terms of, you know, you flag every piece of code, every line of code that you write, and you continuously push it to production, right? So this will eventually help you, because all of your code is actually reaching the production environment, and it is, again, gated, right? So this helps in speedy deployments, as well as this particular merge conflicts. Those sort of problems are, you know, avoided to very high, you know, to a large extent. Additionally, I think the branches that all the developers would actually create, I think, you know, having default rules where branches are deleted when they are being merged, right? So those kind of strategies help. But eventually, I think DevOps is the key, where, you know, we have to actually clean up if those are not happening, because, again, developers can actually remove those flags. It's very easy to do that.
Right.
So yeah, I think regular cleanups have been the key.
Right. Thanks. Vibhor, anything on it?
Yeah, I was just saying that, you know, having the practice in place, and, you know, having a workflow in place, and whenever the branch is getting merged, it will be deleted, say archived for a week, and, you know, permanently deleted after a week. So that, you know, revert back is also possible, and an automation in place. So but I think these days the repositories provides this feature as well, the workflows. So having those workflows in place can also solve this problem.
Thanks, Vibhor. So the next is again to Avinash, like what all matrices you are following for making sure like the DevOps remains within the time frame window, and when any of the CXOs looks at it or ask you, like, give me the matrices, like how many MTTR, MTTD, and all those kind of things. So how are you producing in Physics Wallah?
So I think one metric that we follow for all the microservices in general is the SLOs. So it covers lot of factors. So we have defined a benchmark SLO for all the services, and SLO would essentially contain all the, you know, your error rate, your latency, or even that gives you sort of a single number which you can actually track, and you can check the health of your entire system. But in general, I think that there are a few other things that we do track, which is around how many deployments we are doing on a daily basis, right? And then how quickly can our code from being committed, it actually lands in production. So this kind of metrics is something we are also tracking. And another key metric that that is interesting to track is which you were also mentioning, mean time to recovery.
Right.
So that actually tells us how resilient your system is, how great automations you have in place which can actually help in recovering the system, or even if let's say you are doing it manually. So those things, and then around alerts. So having alerts which can actually inform the team, plus if it can actually trigger some lambdas or Jenkins pipeline to actually maybe cover 20-30% of the cases. So alerts help in improving the mean time to detection, and then logs again, probably when you are working on logs. So how quickly can you detect an issue using the logs? So these are the primarily metrics that actually helps us determine the health of DevOps in general.
Okay, thanks. Jasprit?
Yeah, I'd like to add to that. I think one thing is to understand is that every piece of technology will have different metrics to sort of track, right? Like say, for example, backend services will have latency, throughput, and errors to be tracked, right? For example, infrastructure will have CPU, disk, memory, I/O to be tracked, right? Similarly, for CI/CD pipeline, I think it's important on the same lines which Avinash was also mentioning. It's called DORA metrics, right? Which is basically the time it takes to ship the code, commit, etc. Successful deployments, time between successful deployments and changes, right? So I think those are the metrics which are extremely important. And yeah, it all depends upon which particular piece of technology you're tracking. Relevant metrics kind of also change according to that.
Okay, thanks, Jasprit. So Sachin, one question for you, like, is there a human element in it? Like, how can a DevOps team effectively integrate the human expertise to automated log system?
Absolutely.
Okay.
So human element is who is going to develop that AI. The first human element is this. Okay. Now, if I just look into those AI predictive analysis, log monitoring, everything, in any situation, whatever is being generated, whatever alerts are being generated, it has to be looked upon by human. It is not that machines cannot do it. If you look at it, you can do auto healing.
Right.
As I said that Azure was already doing that. But sometimes there are false alerts that are generated. For example, if you look at CPU spikes, yes, CPU spikes are happening and you are at 80 to 90% of it. But, when you trigger the alerts, it's basically, okay, after 20 minutes of this CPU spike, you are triggering the alert, and shell system go into auto healing mode. I believe it's a decision which depends on application to application.
Right.
So in some cases, you can go ahead and definitely put that auto healing. But in a lot of cases, you will have to go in and check what's really going on. And if it's a legitimate stuff and we are going to get the CPU back on its own, that's fine. Let's not take any action. On top of that, the second thing is, for example, CI/CD pipeline. And if we have put in the AI ops on top of that, putting in the right set of test cases, making sure that obsolete functionalities are taken care of. We have to remove those obsolete test cases, because what happens that based on those obsolete stuff, the AI will start generating wrong prediction. So, and then on top of this, continuously improving the model. Looking at the latest trends, we have to go ahead and continuously improve the model, and that's all the human element and human intelligence involved into this. So AI, definitely wherever we need to automate some repetitive tasks, that's where AI comes in.
Right.
And wherever we need to take certain decisions, so there are some complex deployments, there are complex scenarios that needs to be analyzed, that's human. So artificial intelligence is always augmenting human intelligence. It is not replacing the human intelligence, right?
Got it.
Okay.
Thanks, Sachin. Pratap, anything?
Yes, absolutely. You mentioned one thing is correct. That AI is to augment, right? Where you need a balance between human and AI ops. But the fundamental thing about automation is that understanding the problem statement which you have. And when you automate, it is not the responsibility of the DevOps team to own that, right? It is like, enable.
Right.
So DevOps team has to work as an enabler, not like, support function where we have to, look into the uses of CPU and memory. This is kind of, you're still living in the break fix era, which was kind of a support thing, right? So that is where you work in a way that you can offload more and more so that you can adopt more and more, right? So that is a fundamental problem statement which I want to just add on to that.
Okay.
One more thing which I would like to add, there are always edge cases.
Yes.
So
yes.
those edge cases cannot be taken care by AI. That's very, very important. If you have a customer workflow that's working, if you have a customer business critical flow that's going on, and we start receiving alerts that my system is kind of boiling the ocean, and we have auto scaled everything and still it is boiling the ocean, you need to go ahead and look into that. If it's a customer business flow that is business critical, and you cannot just go ahead and restart the system on its own.
Right.
So we always have to look into some of the common patterns. AI will generate the common patterns based on the log analysis, and based on those common patterns, taking decisions are easy, but the complex decisions are always taken by humans. Not always taken by humans, they can be taken by AI too. But we have to build our AI model, and we have to continuously improve our AI model. That
model,
is
yes.
again a human intervention.
Right.
Okay.
Yeah. Thanks, Sachin. So Avinash, one last question to you. Surya.
Yeah.
Sorry, Avinash. Yeah. So, when we are using all these tools and technologies, usually it happens we always miss the testing integrating within that particular pipeline, right? So how to do that? From the start itself, it has to be testing enabled, so that at least smoke test, at least the regression which we fire in the night, which can be reduced to from 1,000 test cases, it can be reduced to 200 test cases, and then it can be done. So, do you have any opinion on that?
Yeah, I think testing is one area which often never gets discussed because it was never a buzzword.
Right.
But I believe there are different levels of testing that teams have to look at depending on the kind of activities that the development teams do. Broadly, say for example for bug fixing, there could be a different kind of test versus a feature enhancement or a new development as such. Having a smoke test suite and a regression test suite, and using it appropriately, it's not that we have to run everything every time, because it's also time consuming. So first thing is having a daily job, maybe in the night, would give the results so that the teams can come and review when the code is in the pipeline to production, is one aspect. Second, a key aspect is as the applications grow, I believe the number of test cases would grow. So parallelizing the test cases would save a lot of time in terms of giving us the quick feedback.
Right.
So
Right.
that's the thing. Yeah.
Yeah. Anybody else wanted to give an opinion on that?
Yeah, I think so. Testing is a very important aspect of a
Right.
CI/CD to be completed. I mean, testing, so we should not miss at all. So I think like you said, it has to be incorporated from the start. So I think promoting a unit test cases by the developers is a very important thing, which is a very important step. Which I know there will always be a pressure from the business, but having that standard in place that the developers write the unit test case from the before writing a function or a code.
Right.
Is very important, and incorporating those execution of unit test cases in your pipeline is a key for this. I mean, and this is a very important thing to have.
Right.
I want to add another perspective to this. The perspective is, yes, testing is an important,
Right.
but let's not make it overkill, because sometimes it happens that, in legacy applications, we have faced situations. Okay, we are doing extensive testing. I have written down 20,000 test cases. Now that running those test cases itself is taking 10 hours. Then there is no use of that pipeline. So we have to see that what are the test cases which are very important that should be integrated with CI/CD pipeline, And we should always continuously evaluate our test cases and remove the deprecated ones. Right.
Thanks, Sachin, for that.